Okay, today we're going to be looking at something that's a little bit more tricky. So before you watch today's video, please again make sure that you watch the erase video and the video that I recorded and posted for you yesterday as well. If you've watched both of those and you're ready for the next challenge, then that is great. We're going to be having a look at some rectilinear shapes today. Okay, so here you can see that I've got a rectilinear shape on my PowerPoint. Now, a rectilinear shape looks like a shape that could be made up of two different rectangles put together. So it's a more complicated shape than a rectangle. It's got the similar properties to a rectangle and a square. It's got straight lines. It has corners that meet at right angles. But like I said before, it almost looks like two rectangles could have been put together. So actually, to solve the area of this rectilinear shape, we are going to separate it into two rectangles because based on the learning we did yesterday, you have got a really shortcut method of working out the area inside a shape by using your knowledge of multiplication. So here we can't just do length times width. This was the example from yesterday where I had 5 counters or squares going down and I had 7 going across. So we knew that there was an area of 35. Now for this shape, you can see in the top right hand corner, actually there are 6 squares that have been taken away. So we could work it out by saying, well, 5 times 7 is 35, but then it's 6 less. But that might not always be an appropriate method. It might not always be that obvious. So I'm going to show you how I would divide this shape into two separate sections, calculate the areas of both of them, and then add them together to work out the total area. So looking at this shape here in front of you, can you see somewhere where you could draw a straight line and it would split this rectilinear shape into two rectangles, or a rectangle and a square? So instead of looking like it's almost got two pushed together, you would separate them back into separate shapes. Here we have the same shape, again with all of the counters in. You can see that there are 6 in the top right hand corner that we haven't got, so we couldn't just do length times width because those would be missing. The area isn't as large as 35. Now, this is what I mean by cutting your shape. Can you see there is a pink line that has gone horizontally across the shape? Now, if I were to cut the shape along those lines, and actually if we were in school, then what we would have done is we would have actually physically cut them. But hopefully you can visualize that actually if I cut that there, it wouldn't give me two rectangles. It would be one long rectangle at the bottom, but then I'd still have a rectilinear shape at the top. So that couldn't be right. If I cut the paper down that line, that would split the shape into two, but again, wouldn't split it into two rectangles. Hopefully you've got an answer. Now I've given you two examples that wouldn't work. That wouldn't work either. Hopefully you can see, again, I would have that rectangle on one side, but the other shape is not a rectangle or a square. Again, it's still rectilinear. There we go. Now, you might have said that we could cut it straight down there. And then hopefully you can see then that would have split that rectilinear shape into a rectangle on the left-hand side and a square on the right-hand side. Let me show you by changing the color of the counters. Here we go. So same shape. We're going to work out the area. We know that the area is less than 35. But because I've now divided that shape into two parts and they're both now their own separate arrays, we could work out the area of each section and then we can add them together to work out the area of the shape altogether. So if we look at the yellow section first, I've got 4, 1, 2, 3, 4, 5. So I've got 5 groups of 4, or I could say I've got 4 groups of 5. So altogether, on the yellow part of this shape, I have an area of 20 squares. Now on the blue area of the shape, on the right-hand side, you can see I have got 3 groups of 3. Well, 3 times 3 is 9. If I then added those two together, I could find out the area altogether of the total rectilinear shape, which would give me a total of 29 centimeters squared. Now, this isn't drawn to scale, but if they were square centimeters, that would be the measure. That would be how we would write that down, 29 cm, and then that small 2 means squared. So altogether is 29 centimeters squared. Actually, When I first showed you the whole thing without those 6 squares and counters taken away, it would have been a 5 by 7 rectangle, which would have given me a total of 35 square centimeters. And then without those 6, 35 subtract 6 gives me 29 squares. So actually that's a good way of checking or estimating to see whether that is a sensible answer, whether I'm in the right ballpark. So hopefully you can see by splitting that shape into 2 different rectangles, or a square and a rectangle, I have been able to work out the answer, still using a faster method of multiplication instead of adding by 1 each time. Now, whilst I asked you at the start to find a way to cut this shape, you may well have thought of a different way, and you might be sitting there now thinking, I have another way of working this out, which uses the same logic, but in a slightly different way. We could have also cut the shape like this horizontally. Again, you can see it's exactly the same shape. We know that it's got an area of 29 squares, but this time I've cut it so that I've got a smaller yellow rectangle at the top, the bit that kind of pops out, and then I've got that larger rectangle at the bottom. But I can use the same maths here. If you look at the top, you can see clearly I've got 2 rows of 4. Well, the yellow part of the shape will have an area of 8 squares. And I can do that, I can work that out without having to count each one individually. Now the blue section is larger. It is 3 by 7. So 7 threes are 21. That should add up together to make the same area, because it's the same shape. It doesn't matter whether I cut it down the side or across the top. By the time I've worked out each separate section and then added them back together, I should be getting the same answer. So 21 plus 8 does give me a total of 29 centimeters squared. Again, not drawn to scale. So we know that we've got the right answer. We've worked it out 3 different ways, and actually every single time we're getting the same answer. Hopefully that makes sense to you. Now, we couldn't have cut it any other ways, because like I showed you the non-examples at the beginning of this video, you can't cut it in a way that doesn't separate it into 2 rectangles, or a rectangle and a square. Otherwise, you cut a bit off, and you'd still be left with what is a rectilinear shape, and you can't use arrays for shapes that aren't rectangles or squares. That it just doesn't work.